Now, the first thing that you've got to try and understand is, Jason, what are you doing? There's a lot to understand. What the question is. Now, if you read the first paragraph, there's some key things to take out of it. First of all, changing weather. So the key things in the first paragraph, changing weather over the years. So obviously, we're looking at changing something. The next thing is, what are we changing? And it's maximum temperature, month by month, year by year. So straight away from there you think, I need to find a way to show changing weather over the months, year by year. And they're doing that by looking at one part of the weather, and that is simply maximum temperature in a month. So that's the only thing that he's looking at. So you've got max temp in a month, year by year, and you're only looking at, is summer getting longer? Is it warmer and longer? So there's two things. So that's where you start thinking before you even look at the data. Is summer getting warmer and longer? So obviously if you get warmer, the summer months increase maximum temperature because that's the only value we're looking at. And is it getting longer? So are the months around summer getting average maximum temperature getting greater? So that's the starting point. And that's where you start to look at it before you even worry about looking at the actual data set. That's where you would start thinking, okay, this is the sort of data that I need to look at. Months around summer. Okay, so that gives you an idea about what you need, what information you need to find. Next thing. Scrolling down a little bit. Designing the solution. What is Oliver trying to achieve? Well, it's kind of this. But you want to put it in a sentence structure, not just dot points. So the purpose of creating the solution. Is summer getting warmer and longer? Warmer, longer, to justify swimming pool. Swimming pool, blah, blah. So that's the purpose of the solution. And you may or may not want to mention there it's using monthly maximum temperature. But that's sort of secondary because that's part of the solution. Right, identify relevant data to create the solution from the data set supplied. Well, I've kind of gone over that at the start here. The relevant data is going to be max temp per month for months 12, 1, 2, 3. December, January, February, March. And you can decide how long the data's got to go over for. I went right back to the start to get a bigger trend. If you only used a couple of years or a decade, you've got to justify why you think that's a long enough time frame for your data set to show a trend. Personally, I would not think 10 years would be enough to show a shift in temperature because the range of data is too small. So I went back 100 years. Right. Now, what I said earlier or the other day is you can do the spreadsheet first and then produce the layout diagram, that's fine. But whatever you do in your layout diagram, in your spreadsheet, you should put in your layout diagram. And I had a little go at it. Didn't do anything too drastic. Certainly didn't format it in any fashion.
I need a recording stand.
So I've got two two things here. Doesn't even work. Oh yeah. What I did, and again, this is only because this is what I really wanted to do, is the maximum temperature, and I put a 10-year running average. Now this is something you probably aren't aware of, but in order to stop your graph doing this, which is hard to read, a 10-year running average smooths it out, so it looks more like this.
Hey, I did a average.
Alright, so if you do a 10-year running average, and you can see by the formula here, that's the average of this bit. This one here is the average of the ones underneath it, the next 10 years, and so on and so forth. And that's the data that I graphed. And I graphed January, February, December, and March all separately, because I wanted to show, first of all, is there an increase in maximum temperature for each month? And comparing the months, is there a trend that December and March are increasing their temperatures compared to January and February? So that's how I got my data set, and I drew a layout diagram that just represented that. So I didn't format my spreadsheet chart or anything like that. I don't care about formatting at this stage, because it's the graph that's showing the information. The data sheet or the spreadsheet isn't showing information to the end user. That's just an idea to get the information so you can create a graph from it. And here is my graph. You can see January, February, March and December. Now I could put a trend line over that, an actual trend line which will show a trend from the start of the data to the end of the data. And it might end up a little bit, ever so slightly going up, because a trend line is a straight line. And you can do that too. But if I vaguely looked at my data here, I can see that December starts at a little bit at between 38 and 40, sort of 39.5, and it finishes at 39.5. And sort of the last 12 years or so, it's sort of heading up a little bit, but it's gone down a bit from 1967, which kind of puts a light of global warming in some ways, because it's December and it's going down over the period that global warming said it should all go up. But that's a separate political issue. You can see February is going up from here in general. What's that, December? Oh no, I've got two Decembers. How the hell does that work?
No, yeah, one December, one January.
Yeah, alright, sounds good. Black's actually January, I don't know why that's there. Let's rub that out. December sort of starts here. Overall, it's gone down. December, sort of gone up, but down. And March has sort of stayed the same. Sort of gone up a bit from this point, down a bit from this point. From that point there, 1928, it's roughly gone up a little bit, but only by a degree, 34 average to 35 average from here to here. So these are all sorts of things that the graph's got to show in order for you to put your information out. Now, so if I've summarised all that, I would say January hasn't changed, that's a summer month, but he doesn't really want to look at summer months, January and February, because he knows that they're hot enough. January and February, he already knows that they are hot enough to justify it. February has gone, in general, has gone up a little bit over the time, particularly in the last, from this point on, the last 50 years or so. March and December are the important ones. December has gone down a little bit, and March has stayed the same over 100 years, but it's gone up a little bit in the last 50 years. And as it approached January and February, well, you could sort of make an argument that it has, but is 1 degree enough? Is an maximum average temperature of 35 degrees enough to justify a swimming pool? So these are judgment calls. And this is where it gets a little bit tricky if you don't really, not really confident in making these sorts of calls. But what I would do if I was going to create a summary of the graph shown, I would say, I would basically write all that. I would say January hasn't changed over 100 years. It's gone down in the last 50 years, but in the last 12 years it's gone back up again. That's exactly what I would say. You've got a brief couple of sentences on each line. February, over the 100 years, has risen by 3/4 of a degree, average maximum temperature. What's this one? December has actually gone down. But in the last 12 years, it started to reverse its trend and go back up again, much like February has. And March has stayed the same over the 100 years. It's fluctuated a little bit. And in the last 50 years, it's risen an average of 1 degree. So you need to summarise each of those lines in a sentence or two. And that's just describing the graph. That's simply describing what you see there. And the hardest bit at the end is to say, does it justify it? Now, what do you reckon? This is where it comes, this is where it's a little bit harder. Because you've got to make a judgment call on this. Using what information you've been given, what information Oliver wants to get out of it. What do you reckon? Huh? Build it? Don't build it? Put it to his mates?
So what are the macros going to do?
They changed the formula behind it. So this one is all of the...
Don't do it on PC.
Oh, there you go, there's a linear... Oh, maybe it's a trend line. I can't remember. I did this last year. I can't remember what I did before. And you can see February's gone up. January stayed the same. March has gone down a little bit.
How do you make the macros change?
I've got no idea. I do actually, but it's there. I don't want to go into it just yet. I'll go into it later on if you want to see. So, as you can see, there are a lot of judgment calls in here. And you can change how the data looks. If you decide that he wants to build a swimming pool, or if he's really got his heart set on a swimming pool, then you can use use this data here and say, okay, this bit here shows that January and February have gone up, December's gone up, and March has stayed the same. And then you can say, okay, given that those 3 of the months have risen slightly, yes, it has got generally warmer, and the months around summer have got warmer, so summer is getting longer. Because they're the 2 things that you need to answer. Has there been an increase in maximum temperature? And has the months around summer increased also? So these are all the sorts of things you need to think about when you're designing a solution. And this is the sort of idea that you want to get when you're looking at the actual SAC. So again, lots of data that you needed, lots of data that you didn't need. Getting the data out of a PDF into an Excel spreadsheet is sort of a bit different. Hello, Mrs. Miller. Finally stop recording.